This is a galaxy. Galaxies are large collections of dust, gas, and billions of stars in our universe. The gas inside a galaxy will compress and form stars, and when those stars reach the end of their lifetime, the gas is ejected and reused to form new stars. When we look at galaxies that are close to ours, we notice that the amount of new stars being formed is little to none, which means there is some mechanism by which galaxies are losing their gas and star formation is being suppressed or shut down. This process is known as quenching. Astronomers want to understand what this mechanism is to complete our picture of what a galaxy's life looks like. The quenching mechanism of a galaxy is dependent on its age, the mass, and what type of stars make up a galaxy. And each of these properties can be determined from the light that we observe from a galaxy, also known as a galaxy's spectrum. You may be familiar with the concept of a prism, which splits light into a rainbow, and astronomers do a similar thing with light from a galaxy, splitting the light into a spectrum. We as humans only see a small portion of the entire light spectrum, but galaxies emit light over a large range of wavelengths, and the spectrum is going to look something like this. When we look at a galaxy spectrum, we are seeing all the light from the galaxy, which is dominated by the hottest and the brightest stars, which also happen to have the shortest lifespan. This means that once these stars burn up their gas and die, we'll see no more light in that portion of the spectrum. So, based on the light that we see, we can estimate what stars currently make up the galaxy and that galaxy's age. From here, we can actually reproduce what the rate of star formation was as the galaxy evolved, known as the star formation history, and shown as a smaller graph inside the spectrum here. We can notice how quickly a galaxy became quenched to better understand what quenching mechanism may have been at play. What I'm doing is looking at spectra for approximately 50 galaxies in a cluster and determining their star formation history graphs to better understand their quenching mechanism and to further the collective knowledge of galaxy evolution.